click, off, click. Your nitrile gloves. Discharge. So hello and welcome to Starborn Science. Today we will be exploring resonant inductive coupling. Now we will be exploring how to power this lamp over here through this air gap through these two pancake coils. But I need your attention here for a while. So, I'm gonna explain real fast how the power chain of the whole thing runs. So, this is not magic, this is physics. So, what we have is a battery, of course, a power source, and a boost converter that boosts the voltage of this battery from 16 to 50 volts. Then we have what's called a Mazilli ZVS driver. ZVS stands for zero voltage switching, that converts this voltage to high frequency AC voltage and runs it through this pancake coil through the first one, the upper one. Then we have the coil that's on the other side that receives this magnetic field that is produced from the upper coil, and a voltage is induced in this secondary coil. And we have what's called the full bridge rectifier connected to this coil that takes this voltage and rectifies it through some very fast diodes called Schottky diodes. And we have smoothing capacitors that take this rectified voltage and smooth it into DC. And we have a pulse generator that takes this DC voltage and pulses it through a MOSFET to a high voltage transformer that steps it up to 220 volts AC that powers the lamp. So here is the pulse generator. As you can see, it's set at 25 kHz and 25% duty cycle. Usually, duty cycle increases the power to the load. In this specific setup, it actually increases the power to the load when it's decreased, since the capacitors get more time to charge during pulses if they are discharged more slowly per cycle. So this is the MOSFET that pulses the current through the high voltage transformer. This is the lamp. This is a small converter that runs the generator. This is the Schottky diodes that form the full bridge rectifier, they are heat sinked because of the high currents running through here. These are the smoothing capacitors. This is the R.I.C coil, this is the TX coil, this is the ZVS driver, this is the step-up converter, and this is the battery pack. So now I'll go over there and connect the power and show you that once I do, the lamp will light up. If I move the coil away, the lamp lights up more or less. So as you can see, this is not magic, this is physics. Now, of course, if we want to, we can also power a fluorescent lamp. The transformer's voltage is limited by the load due to the voltage drop caused by the load when it's applied. So we can definitely light up a fluorescent bulb because the output of this transformer is in the kilovolt range. So let me demonstrate. Sadly, I have just a black light CFL, but that will do for the demo. So you can see it gets fully lit. Now I know you're probably gonna call me insane, but I've built 2 rigs because one apparently wasn't enough. I went into building 2 rigs, yes, because the second is better because it sports a choke too. A choke is there to smooth out the AC coming from the R.I.C coil to make the waveform of the R.I.C coil better and thus improve the height from which these coils can interact, because it improves resonance in that way. It acts as a DC current source in a sense. But in any way, as I promised, now we're gonna light the low voltage, high current 75 watt lamp. And there you go. You could see the 30 Hz flicker too. So this is the second rig, and of course it can perform the same tricks as well. So no need to explain further what it does and how it does it. So what is the point of the video? Well, is wireless power cool? Yes. Is it efficient when you wanna transfer power to a load? No. A wire is a lot more efficient. You connect the lamp to a wire and you connect it to the mains on the wall and the lamp lights up. You do not need high frequency converters, punky coils, full bridge rectifiers, pulse generators, and so on and so forth. Yet, if you do wanna power something wirelessly, suddenly a wire disqualifies. So this video isn't here to glorify wireless power as some kind of mystical form of free energy or anything short of that. It's just to demonstrate the fundamentals of resonant inductive coupling, which is what happens with wireless power transmission, which is what we have thanks to Mr. Nikola Tesla. I think we deserve him some credit for it. So yeah, this is the primary waveform only at 16 volts, because at 50 volts it would fry my scope and I couldn't measure the amplitude anyways. Now the probe is connected to the receiver coil, and as you can see, it's resonating at exactly the same frequency, 200 to 220 kilohertz. So there's your proof about resonant inductive coupling. The system is resonant. In any case, that was the fundamentals of resonant inductive coupling. Again, battery, stepping the voltage up, high frequency AC, two coils exchange magnetic fields, a voltage is induced in the second coil, an array of diodes rectifies that voltage, the capacitors smooth out that voltage, a MOSFET transistor powered by a pulse generator pulses that voltage through a primary coil of a transformer. The secondary coil of the transformer builds up voltage and powers the load, which in our case is a lamp. I think it's pretty simple to understand. There's no magic, just physics again. So yeah, I hope you enjoyed this episode of Starborn Science. Keep dreaming, keep exploring, and I will see you in the next one.